Okay, so in this video we are going to do the cylindrical shell method, and we're going to rotate around the x-axis. So everything is going to be in terms of y this time. Now again, I'm doing this all shorthand, but make sure you understand when you read the problem to get the information. So this is, I just wrote down the important information for the problem. So we're going to be bounded by this function here. So this is going to be bounded to the right, and we're going to be bounded on the left by the y-axis, and this is going to be the interval that we're going to be bounded by. So y equals 0 to y equals 4. So this is our C and D. Okay, and then of course we're revolving around the x-axis. So again, so since we're using the cylindrical shell method, in this case we are going to find the volume by doing CD 2 pi y g of y dy. Okay, and so again, I would sketch the graph just so you know. So let's sketch the graph. Okay, so if you sketch the graph of 2 square root y, okay, 2 square root y looks something like this. Okay, so we're going from 0 to 4. So this is the area. And we are rotating this around the x-axis. And so if we rotate around the x-axis, you can kind of visualize what we're doing. So then our rectangles, again, are going parallel to the axis of rotation, right? So that means everything is in terms of y. Everything has to be in terms of y. This is dy, right? So everything has to be in terms of y. So even if the function is given in terms of x, you have to write it as a function of y, okay? So again, so plug it into this formula. So this here is already a function of y, so we're good. So now let's just plug it in. So 0 to 4, we're going to take the 2 pi outside of the integral, or the integrand. And what do we get? We get y times g of y, which is 2 times the square root of y dy. And now what are we going to do? So we're going to simplify this, right? So this is y to the 1/2, y to the 2/2, if you will. And so we're going to combine those, and we get 2 pi from 0 to 4 of 2 y to the 3/2. Okay, and then of course we could pull the 2 out, and so we get 2 times 2, which is 4, so this will be 4 pi dy. Okay, so now we can integrate this easily, right? So this is going to become 4 pi times what? Well, this is going to increase by 1, so that's going to be 5 pi, so it's going to be 2/5 y to the 5/2. And we're going to go from 0 to 4. Okay? And so now, what does this equal? Well, we pull the 4/5, so that's going to be 8/5. So the 2/5 come out, so we're going to get 8/5 pi, and we're going to evaluate this at 4 and 0. Well, at 0, this is just 0, the whole thing's 0, so we can just evaluate it at 4 and we're done, because we're just going to end up subtracting off 0. So this is going to be what? 4 to the 5/2. Well, remember, this is 4 and 1/2. 4 to the 1/2 is the same as the square root of 4, so that's going to be 2. And then we take 2 to the 5th. Well, 2 to the 5th, what's that? Well, that's 2, 4, 8, 16, what? 32, right? So you get 32 here. So this is going to be what? You get 8 times 32 divided by 5. Right? So again, double check that. So that's 2. Yeah. So 32 times 8. So that's going to be 32 times 8 is 240 plus 16, so 256. So 250, yeah, so that's it. 256 over 5 pi. And of course, I would rewrite this as you can rewrite this as a mixed number, which is going to be, oh, wait a minute. Oops. That should be 51 and 1/5 pi. Okay, and like always, here is yours. Okay, so again, I'm going to read it to you and just write down the important information for you. So it says define Q as the region bounded on the right by the graph of g of y equals 3 over y, and on the left by the y-axis. And this is going to be for the interval, for all y in the interval, 1 to 3. And it says find the volume of the solid revolution formed by revolving Q around the x-axis. So we're going around the x-axis. Okay, so that's what I want you guys to work on, and as usual, let me know if you have any questions or run into any problems.